The purpose of today's lesson is to write equations to solve real-world problems. The first one is, the graph below shows a trip taken by a car where x is time in hours the car has driven, and y is the distance in miles from Salt Lake City. Label the axis of the graph. Okay, well we can see x is time and we have to put in hours. So let's fill that in, time and hours. And then of course your distance is your y, and we have to be specific and put miles because we don't know if it's inches, feet, or what. Okay, and then we have to write an equation. So let's take a look here and let's find information. Well, it looks like the y-axis is here, or the y-intercept, and it goes up, and I feel like it hits about right here. Okay, so the rise is going to be up and over. Let's count. So that's 50 to 350, so that's 300, the rise, and it looks like it goes over 5. So as we have done, you find the slope, 300 over 5, which is 60, and the y-intercept, where it crosses the y-axis, is at 50. So y equals 60x plus 50. Use your graph and equation to tell the story of this trip taken by the car. Okay, it looks like a car started a trip 50 miles from Salt Lake City. From Salt Lake City, I'm abbreviating, at a constant rate of 60 miles per hour, 60 miles per hour, and it's only for 10 hours because you can see that the line stops up here. Look at it, stops right here. And when is that? It stops at 10. Okay, so that's the first one. The next one is, the graph below shows the weight of a baby elephant where x is the time in weeks since the elephant's birth and y is the weight in pounds. At 4 weeks, the elephant weighed 352 pounds. Whoa. And at 12 weeks, the elephant weighed 592 pounds. Label the axis of the graph. Holy cow, that's a big elephant. Okay, graph, x, time, and this is in weeks. And this is weight. Can you imagine holding that? I guess you couldn't. Pounds. We'll abbreviate pounds. Okay, looks like we've got weeks, pounds. So that's how our points are going to be set up. Weeks and pounds, right? Because this is x and this is y. So it's going to be weeks and pounds. We're going to need this space down here to work this out. 4 weeks, the elephant is at 352 pounds, and at 12 weeks, 592. Okay, so we're familiar with how to solve these. We have to find the slope. Let's make note of that. We need the slope, and of course we need the y-intercept. Okay, well, we're going to have to find the slope first, and we remember using 2 points, you subtract the y's over the x's. 12 minus 4. And that's going to give us 240 over 8, which is 30. So I have my slope. Do I have my y-intercept? Oh man, it's not on. It's there, but I'm not sure exactly what the number is. So I have to go algebraically to find that. So we're going to choose one of the 2 points. And I'm going to choose 352. So I'm going to use this point, and I'm going to use the slope. So 352 equals slope x plus b. This is going to find my y-intercept for me. 120 plus b, 352, subtract the 120, and I get 242. JK, 232. Come on, Monahan, do the math. 232. So 232 is my y-intercept. So the equation is, let me get a darker color here, y equals 30x plus 232. Use your graph and equation to tell the story. Okay. The elephant weight at birth, I'm not going to write the rest, I'm just going to say it, was 232 pounds. It grew at a constant rate of 30 pounds per week for the first 20 weeks of its life. So you have to listen to this last part because I'm not going to write it down. So you have to listen. Okay? The next parts, the graph below shows the relationship between the temperature in degrees Celsius and the temperature in Fahrenheit. Okay, let's take a look at this. I can see a point. I see 2 points. So always we're trying to find M and B. And then we can use one of the points after we find the M. So we're going to use the 2 points 0, 32 and negative 10, 14. We're going to find the slope by doing 14 minus 32 over negative 10 minus 0. And that's going to give us 16 over 5, which is 8/5. Okay, so I have my slope. That's 8/5. Now I have to use one of the points. I'm going to use 0, 32. Anytime there's a simple number and it doesn't have negatives, that's the point I'm going to use. Okay. Wow, I don't know, where am I supposed to do this work? Yikes! Alright, so we're going to have to write small. So I'm going to do 32 equals 8/5 times 0 plus b. Oh, good. So b is 32. So b is 32, and I used point 032. So my equation is y equals 8/5 x plus 32. Okay, let's take a look at this next one. Peter is draining his hot tub so he can clean it. He puts a hose in the hot tub to drain the water at a constant rate. After 5 minutes, there were 430 gallons of water left in the hot tub. After 20 minutes, there are 370. Let x be time in minutes. I like to write this. I'm going to put minutes is my x and gallons is my y. Okay. So now I set up my 2 points, 5 and 430, and 20 and 370. Let's find our slope and our y-intercept. Slope, of course, we're familiar with this. Go backwards this way and that way. So slope is 370 minus 430 over 20 minus 5. And that gives me a slope of, I'm going to pause. Alright, it's negative 60 over, or positive, nope, it's negative, over 15, which gives me negative 4 is my slope. I have to find my y-intercept. So which point am I going to use? I'm going to use this point to figure that out. Let's go green here, back to a pen. And that's going to be 430 equals slope negative 4.5 or the x is 5, negative 20, plus b, 430, so 450 equals b. So my final equation is going to be negative 4x plus 450. Use your equation to add more details to the story of Peter draining, okay? He drained at a constant rate, of 4 gallons per minute. What did he drained it at a constant rate of 4 gallons per minute. This means you have to listen. That's an ear there. That's going to be my ear symbol. So that means you have to listen. You can't just copy. A handyman charges $40 an hour plus the cost of material. Roseanne received a bill from the handyman for $477 for 8 hours of work. Okay. So the slope is 40 and it's dollars per hour. Okay. I like to write this. I like to write hours and dollars. So then I know how my point should be written. 8,477. So you're going to be able to put your point in using y equals mx plus b. Slope. Okay, we got 320. 477. 320, that'd be let's see, what is that? Subtraction 157. That's B. So I have my slope, 40x plus B. Oh, B is 157. All right, get to 157. Use your equation, add more details. The cost of materials was $157. Here's where you're listening. The cost of materials was $157. You have to listen to write that down. Okay, the next one. We got a table. We got height in feet, air balloon, T minutes. Let's see, this is a change of 3. This is a change of 450. Right off the bat, I know my slope is 450 over 3, which gives me a 150. Do I have a y-intercept here? No. So I have to use a point. Let's use the point 2, 300. And let's plug that into the equation with our slope. So we would get 300 equals 150 times 2 plus b. So it's 300 equals 300 plus b. Oh, nice. b equals 0. I like that. Y equals 150x. Use the table to tell a little bit more. The balloon starts on the ground and rises at a constant rate. Of 150 feet per minute. At a constant rate of 150 feet per minute. So if you have all this filled in, that tells me you're listening. All right, this concludes our lesson on writing equations to real-world problems.